Hi friends, welcome to Mechanical Explorations. Now in this part, we are going to see about the subject heat transfer. That is, I plan to upload part by part. It will be useful for your in gate preparation and in interview point of view and also in ESE point of view also. So before going to the subject, we need to understand the term what is heat transfer and what is heat. For this, we need to go to some histories how the scientists dedicated their life to define what is heat and what are the things related to heat before they have discussed. And in that, an important scientist in 1802, his name is Sir Thomas Young, and he gave a statement about energy. That is, energy cannot be defined. This is the statement given by Thomas Young. Yes, energy cannot be defined. That is the statement which is already given by him. Till now, that is the thing in regarding energy, because there are a lot of misconception and understanding. There is no understanding what is energy is, and he gave the statement like that. And in 1841, Robert Mayer is a German scientist. Sir gave an first law of thermodynamics, but no one is ready to accept it because the Britishers are not ready to accept it because they are giving the laws. Aggregation is from German, and there is a strong political aggregation of Hitler. So no one want to attend this, accept these things. And in 1843, Sir James Prescott Joule, our scientist, British scientist, Sir Joule came, and he stated the first law of thermodynamics experimentally, and everyone accepted it. And after this first law only, College of Engineering, Roorkee came in India. So, in 1843, Sir Joule came and he gave first law, and everyone accepted it. And regarding this, energy is said to be nothing but Joule only, and its unit is Newton meter. You all know. So, energy is nothing but Joule. So, what is Joule? I can take you by definition, and there is nothing use in it. So, because we are in the thing of understanding, because we need to solve problems, we need to address lot of things. So, for understanding practically what is Joule, that is, we can go for what is 1 kilojoule. If we burn one matchstick and that one matchstick releases energy completely, then whatever the energy given out is termed to be 1 kilojoule. So, if example like 4 kilojoule per kg Kelvin of specific heat of water, then 4 matchstick is required. Similarly, we are going to see in problems like there will be 20,000 kilojoule. So, at that time your understanding should be 20,000 matchsticks is being burnt. So, that much of energy is being given out. So, that is 20,000 kilojoule. Likewise, every statement whatever our scientist gave, it's having one thing. They have never gave anything as simple, just like that. It's a joule, it's a meter. Like for meter also, you know that there is a 2 pole in France, that's distance is meter, so that is taken everywhere to be 1 meter. So likewise, what is 1 Newton is, if you put a apple in your palm and you feel how much weight it you feel is, that is 1 Newton. I hope so you understand what is 1 kilojoule and what is 1 Newton and all. So this is for basic understanding only I have given this. Now coming to the important term temperature. For understanding what is heat and all, the basic term temperature you should know. Regardlessly temperature, you should still, it is a speed of molecule. Irrelevant everywhere in interview point of view for while we are studying for our preparations right now, it is speed of molecules only. And the kinetic theory also states these things only, that is V directly proportional to root T. You know that V is velocity and T is temperature, that is speed of molecule. And I have given in case of gas, you know already that the gas, the molecules are very loosely packed and it is from one place to another place. So the molecules are very largely in distance, and in that time you can define temperature as a speed of molecule, that is how fast it can move. And when it comes to solid, you have to tell, like You have the understanding of solid is the molecules are very closely packed. When there is closely packed, the molecule attraction is also high. So when there is attraction is high, there will be a vibration, and this vibration is nothing but temperature in molecules which is solids. That's all. That is, when it is vibrating fastly, the temperature is high. That is, you will feel hot. Whenever you will feel hot, the vibration is more. Whenever you feel cold, the vibration is less. That's a vice versa. This is the understanding of temperature. So this is what the thing. Neither like hotness or coldness. Please don't address temperature in that point of view. It's completely wrong. And you please take this term. That is speed of molecules. And next thing, we are going to what is total energy. Before going to total energy, you should understand one thing, what we are going to study, what our point of view, that is mechanical engineers point of view, is that energy is lot of energy. There will be chemical energy, nuclear energy, because you are considered molecule, the molecule may have fission, fusion reaction, chemical energy will be there, lot of energy will be there, and whatever we consider is thermal energy only, because our subject is dealing with mechanical and we are going to see only thermal energy, and rest of other energy is that other energy. We don't want that things. Like similar way, if you go for a nuclear engineer, for him the main energy is nuclear energy, for him the thermal energy is other energy. You won't consider these things and all. Likewise, we are going to consider thermal energy in our total energy. So total energy we can't simply describe like that. It has two parts. That's a microscopic approach and also the macroscopic approach. See, initially in microscopic approach, how we are going to define the energy. You already know the microscopic approach, but I will be going in depth so that for your better understand. And you take one molecule. Every molecule has 6 degrees of freedom. It can move in x direction, y direction, z direction, and also it can rotate in 3 directions also. That is 3 angles. And you know that for every 1 degree of freedom, there must be one equation. And for 6 degree of freedom, there is 6 equations. So example, you consider a box that is 25 centimeter cube, whatever I given here. You just listen to me, you need not to take the notes. And in that box, normally the molecule, how many molecules will be present is 10 power 20. You can just calculate 10 power 20, that much molecules will be there. And for one molecule, what I have said, 6 equation is there. For 10 power 20 molecules, multiply by 6, it will be n number of equations. So even the computer can't solve it. That's why that is the thing I have given. It's very difficult for us to solve. So microscopic is a purely imaginary approach, imaginary term, and it is not possible also. So whatever we are talking is about molecular level, that is average molecular level only, not in microscopic level. That thing is termed to be classical thermodynamics. Whatever we are studying here is classical thermodynamics. Hope so you know all those things. I'm just giving a glimpse. So if we say the pressure is 10 bar, whatever our problem, if we say the pressure is 10 bar, we are not going microscopically because it goes inside molecule. It is only molecular level, that is average level or bulk manner, that is classical thermodynamics. And if molecule is having some movement, then must be having some energy. Whatever, if we move, we must have some energy. Same thing in case of molecules also, nothing different. Molecules moves, molecules have some energy. And here I have given these things for your better understanding of microscopic and macroscopic approach. You need not to take these things. You can just listen what I'm saying. It's very much enough. See, if we see inside one molecule, it will have translation motion and other will have rotational motion. In that both the molecules, they are attached to with some energy, right? And they are known as intermolecular forces. The energy in which the two molecules are being attached. Please understand carefully. So when we further go inside, it comes a neutron spin, electron, proton. There are a lot of things, an endless process. So here molecule rotation, which is an activity, because of the activity temperature changes. You got the point, right? How the temperature changes. Molecule is rotating. Molecule is rotating means it will give some vibration. That is, this is an activity. So the temperature is being changed. And we say that intermolecular forces are not molecular activity. I have written here also, you can study afterwards, are not molecular activity. It is means that if any energy inside the intermolecular, it's not reflected outside. Energy inside intermolecular is inside only. It's not reflected outside. That's why the energy inside the intermolecular forces are said to be hidden energy, which I have given below also. Will come later. So this energy related with intermolecular forces are only for molecular forces. That is because of speed of molecules or temperature, what I have said initially. And important thing, we already said temperature because of molecular activity, not because of intermolecular forces. And you take the point, energy associated with intermolecular forces are hidden energy. We study latent energy, right? That latent energy is hidden energy. In Greek, latent is hidden. Same thing. Whatever energy inside, it is intermolecular, it is hidden energy. Hope so you understand this very well. And energy which comes out the intermolecular forces, that is, energy will be absorbed or released, it is termed to be also latent energy. See, if what will happen when the energy is being released, when the molecule is colliding, like the collision is very large and it can't able to withstand, then the molecule, what happens, it will break. Then the molecule breaks, one molecule, another molecule will move far away. What happens? It is a concept of gas. Yes, one molecule, another molecule, which is in far away distance, then we should consider this is as, yeah, this is gas. So when a molecule are colliding, it is in liquid phase or solid phase. When they are broken and they are moving in another direction far away, it comes to gas. This is nothing but phase change, and this phase change is due to the internal hidden energy, or whatever we say latent energy also. That is the thing also I have given. And the molecules will separate. This is related to phase change, and we call this as hidden energy. This is why we call them as hidden energy or latent energy, because they only are making the liquid to water, water to liquid, and solid, and solid to liquid, liquid to gas, gas to solid. All those things are because of this hidden energy only. And you take this thing as temperature, you note down this thing only. This is very important. Temperature change is related to molecular activity, and hidden energy is related to phase change. Other than rest of the thing is not important, because we are going to go through a lot of things. In between that, we need to know all those things, but whatever required only we have to take. We should not write everything. And while going to solve problems, we are going to take every formulas and how to solve the problems. That is another different picture. There we need to take everything. Here just you take the note only. And if one molecule collides with each other, then only it related to temperature change. Yes, collision, vibration will come, temperature will change, more vibration, it is hot, less vibration, it is cold. That's all. If anyone asks what is thermal energy, it is a group of sensible energy and latent energy. Definitions, that is the energy associated with molecular activity like translation, rotation, vibration. It is related to temperature change. This energy is termed to be sensible energy. We already studied, right? And latent energy also the same thing. The energy associated with intermolecular forces is said to be latent energy or hidden energy. And when you combine these two things, the group of sensible energy and latent energy, it is termed to be the thermal energy. Hope so, friends, you understand what is this thing. So I would like to wind up the part 1 here. In next coming part, we will be seeing what is potential energy, kinetic energy, and what mechanical energy, and why to study heat transfer, and why Bernoulli's energy is not related to thermal energy, and also steady flow energy equation, and why we define it. These all the things we are going to study in next part. So you understand, hope so you understand this part. This is very important in interview point of view, and also your understanding point of view for what is heat, what is temperature, all those things. Okay, you understand, I think so. If you have any queries, you can leave in comments so that I can address these things. See you in next part. Thank you. If you like my videos, please subscribe to my channel. Thank you.